Hello. Today I'm going to talk about how you find the tangent and normal to a curve, to a function at a specific point. So we're going to consider the following function. F of x, or y, equals 2x cubed minus 4x squared minus 6x plus 4. So this is a polynomial. We'll have some ups and downs. And we want to find the tangent and normal to this curve at the point x equal minus 1. So in order to get the tangent to the curve at x equal minus 1, we have to determine the slope at minus 1. And from that, we're going to take the derivative. In order to do that, we're going to take the derivative. I think you can see that the derivative of this polynomial is 6x squared minus 8x plus minus 6. And if you substitute minus 1 into this equation, you get 8. So the slope of this function here at x equals minus 1 is 8. All right? So it's a positive derivative, positive slope. So the tangent has a slope of 8. In order to get the equation for the tangent at the point x equals minus 1, you want to determine the value of y at that point. So you substitute minus 1 in for x in this equation, and you will see that you'll get 4. All right? So just, you can do this on your own. Minus 1 for x, and you'll get 4. So at the point in question where we want to find the tangent curve would have to be y tangent would equal plus 8x, 8 is the slope, plus b. And if we substitute minus 1 for x and 4 for y, we can get the value of b. b is 12. So this is the tangent equation. All right. Now, it's easy to show that when the normal to this tangent at that same point, the slope of the normal would be minus 1/8. Okay, the slope of two lines that are perpendicular to one another are the inverse negative to one another. And you can go to Khan Academy or lots of places to see a proof of it. It's very straightforward. I'm not going to do that. So the normal function would be minus x over 8 plus b prime. I'm just distinguish it from the b for this tangent. And if you substitute the two values for x and y, you get a b of 31/8. All right, so this is the normal to the curve at minus 1, 4. And this is the tangent to the curve. Now, how can we check to make sure that's right? All right. Well, I would urge you to, serious math students, to get a plotting program. And there's one in Windows 10, which is called Microsoft Mathematics. It's pretty good. There are lots of very good ones that are used on iPads and iPhones. Okay, so let me okay, here's the function, and okay, this is the function, and this here is the slope, the tangent. You can see that it's tangent to the line, and this point is x equal minus 1, 4, y equals 4, and here's the normal, and you can see that it behaves nicely. Okay, so again, Microsoft Mathematics is available, and there are very good programs on Apple applications on the iPad that I use and like very much. Another way to do this is to use something called Wolfram Alpha. And if you go to the Wolfram Alpha, and let's say we take the function. I already typed this in to save time. And let me put in tangent. Tangent to the function. And we get 8x plus 12, all right, which is what we had. And if we do the normal, I urge you, serious math students, to use Wolfram Alpha. It's a very versatile program. I love it. And now let's do the normal. Of course, you know, you don't want to just calculate these things without understanding how to do them. You want to be able to do it on your own. But this is a way of checking that you didn't make a mistake. And here's the normal, okay? So to review, we started off with the function y equals 2x cubed minus 4x squared minus 6x plus 4. And we wanted to find the normal, well, the tangent equation and the normal equation at x equal minus 1. We found the y value at that point, and it was 4. So minus 1, 4. And every curve has a tangent at a point and a normal at that same point. We found the derivative and plugged in minus 1 and got the slope. The derivative is 8, so the slope of the tangent is 8. We substituted in the linear equation y equals 8x plus b. Substituting minus 1 to 4, we got 12 for the intercept of the tangent. And the normal will have a slope of inverse reciprocal of the slope of the tangent, so minus 1/8. So this is the equation for the normal, and we substitute in the value of x and y to get the intercept for that. So this is the equation for the normal. So it's a very straightforward thing. And then we check the results with a plotting program, which I think is a good thing to do. And we also check the result using Wolfram Alpha. Wolfram Alpha actually gives you a curve as well. Okay, this is for the tangent. Okay, so thank you for your attention, and I'll see you next time.